Hello the Year 8s, Mr. Herman here, and this will be looking at the essential assessment skill, Find Area of Composite Shapes. Learning goals for this lesson is we're going to look into what a composite shape is, and the success criteria is very simply to be able to solve the area of composite shapes. Now, before we delve into the different examples that Essential Assessment has given you, I want to show you what an actual composite shape is. So to put really simply, a composite shape is what seems to look like an irregular shape made up of regular shapes. So what is a regular shape? So all the shapes that you've seen within primary school, so squares, rectangles, triangles, so triangles that look like that, so right angle triangles, or maybe different triangles that look like that. Circles with either a radius or a diameter, which is the full length. Semicircles as well. Quarter circles, kind of the Pac-Man, and even circles that have a portion of it, like the pizza slice. So in between here, there's a certain angle, which I'll put like that. So the little bird, I like to think of it. So the regular shapes are these ones here, the square, rectangle, triangles, and the circles. You can also have parallelograms, rhombuses, but we're not going to delve into that. These ones here, they do look regular, but they're actually composite shapes as well, because they have been manipulated from this regular shape of a circle. And so what you need to make sure is, in order to solve the areas of composite shapes, you need to know your formulas for the area of these shapes here. So right now I've just filled out all the different formulas that you can see within these regular and these composite shapes over here. And all of these are just letters that within your questions will be replaced with numbers. I've just used letters as shorthand notation. The L in the first one, or the square, L just means length. And so to get the area of a square, you just find its length and you square it, or you multiply it by itself, length times length. That's why it's called length square, because it's based off this formula of getting the area of a square. For rectangle, it's the length times the width, so W is equal to width. Now, I had a student ask me before, which one do you deem the length and which one do you deem the width? I was always under the impression that it actually makes no difference, but it does. The length is always considered the longest side of a rectangle, or whatever shape you're talking about. So length is the longest side and width is the shortest. So for area of a rectangle, it's length times width. For a triangle, there's two different types of triangles. B and H stand for base and height. So the base and the height, you're going to get half and you're going to multiply by base and height. Or in other words, get the base and the height together, multiply them together, and just divide it by 2. And you're dividing by 2, or you're halving it, and that's because a triangle is always exactly half a rectangle or half a square, depending on what the base length is. So this is where that half comes from. Same with this type of triangle here. This is half. So that half goes there, that half goes there. So the formula still remains the same: half times base times height. Get your base, get your height, multiply them together, and then half them. For circle, it gets a bit trickier because we're implementing the use of this pi, and remember, pi is equal to 3.14. The R just stands for radius. R stands for radius, and the radius is the measurement from in the middle or the center of the circle to the outside edge. The other dimension that you can think of, if you go all the way across, from end to end of a circle. This is the letter D. D standing for diameter. What you use within your formula is generally, or not generally, I should say always, the letter R. This is always the radius, and it's being squared. So it's pi times radius squared. If a question gives you the diameter, you need to half that so you can get your radius. Okay, so just be mindful. So when you're using the formula and you've been given a diameter, don't just put the diameter straight into the formula. Half it first to get what the radius size is, and then put that radius into your formula. So 3.14 times radius, or times radius squared. Now these shapes here, because this is dealing with a semicircle or a half circle, it's whatever the formula is, and you're just multiplying by half, or you're dividing it by 2, same thing. You're just finding half of what that area is. With the Pac-Man circle, this is just 3/4 of a circle, so you multiply it by 3/4. So you can either have a quarter, or half, or 3/4, maybe 7/8. Sometimes you might get a degree of some sort, so this might be 60 degrees or 45 degrees. The degree, the formula for this one, you just put whatever the degree is on 360, and the reason why it's 360 is because there's 360 degrees in a full circle. You're getting a portion of that angle out of 360. And then again, you just multiply it by pi times the radius squared. And the radius in this case, if I was to draw it on something like this, would be this length here. So, hopefully the first 5 shapes that you see here, regular shapes, you've seen the formulas for before. You may have needed just a little bit of a reminder of what these formulas are. These 3 probably look new to you, but there's nothing different, out of the ordinary, nothing too different. You're just implementing a fraction of some sort, multiplying with it. Okay. Now we're going to utilize knowing these formulas in conjunction with different types of shapes. So maybe a composite shape will be a combination of a rectangle and a square. So it looks something like this. And you have to go ahead and find out what the formula of that is if they've given you certain lengths. Or maybe you have something that looks like this. So we've got the circle there, we've got the semicircle there, and then we've got a rectangle here. Or maybe you have something that looks like this. So this composite shape here is made up of a rectangle and a triangle. These are composite shapes. Okay, these are the type of shapes that you're going to see within your central assessment skill, and you've got to utilize your skill of knowing what the area of these certain shapes are, break it down, add all the areas up together to get your area of a composite shape. Let's have a look at a few examples so you can see how to approach these questions. Alright, here is the first question from the skill. Now, my advice is, because you're doing this in the comfort of your own home, because this is very visual based and there's going to be quite a lot of drawing involved, my recommendation is you have a pen and a notepad readily available, so that way you can sketch down the different shapes that this composite shape is made out of, and then you can write down your answer on a piece of paper, and then that way you can translate it to the actual question itself. And I forgot to put the 4 different solutions that it could be out of. So this composite shape here, we can see that this shape is made up of 2 shapes. The first one is a rectangle, and the second one is a triangle. So rectangle here, plus this triangle, which is here. Bit of a shocking triangle. I got an eraser. Here we go. So the area for a rectangle is quite simple. We know that this length here is 7 kilometers, and this top width here is 4.5 kilometers. And to get the area, it's just length times width. So the area, A for area, is just 7 times 4.5. And this is equal to, grab your calculator out, There we go, scientific calculator, 7 times 4.5. If it comes up like this, just press the SD button and you get 31.5. So 31.5 square kilometers. That little square just indicates that we're dealing with area, 2 dimensions. Here we go. Alright, the triangle is base times height. Now this has been rotated, but we still got to remember that this here is going to be my base length, and this here is going to be my height length. Now the base we already know, because if it's 7 here, it's also going to be 7 here, so 7 kilometers. Now the height, it doesn't necessarily say. This here will be the height. It's been given the full height of this shape, which is 8, and this here is 4.5. This here has to be the remainder to get to 8. So in this case, this is 3.5. This 3.5 plus 4.5 will give me 8. So this here is 3.5 kilometers. My area for this triangle, I'm going to name this one Area 1 and Area 2. So Area 2 is half times base, which is 7, times height, which is 3.5. So go ahead, put this into the calculator. So half, so 1/2, multiply by 7, multiply by 3.5, and this will give me 12.25. 12.25 square kilometers. So now that we've got these two areas of the composite shape, all we've got to do is simply add them. 31.5 plus 12.25, and this right here, this will give me 43.75 square kilometers. So our solution is this one here. So composite shapes, while the working out isn't necessarily too tricky, there is going to be just a little bit more working out because you're working out the areas of both Area 1 and Area 2. Sometimes you can have more than one area. We'll go ahead and we'll try a few other examples to see how to tackle the trickier questions. Alright, this question here is question number 5. We're going to work out the area of this composite shape here. And this composite shape is made up of a rectangle and a semicircle or half circle. So the area, 3.1 meters for the width and 4.6 meters for the length. So the area of this rectangle here, area 1 is just 3.1 multiplied by 4.6. So 3.1 multiplied by 4.6. This is equal to 14.26. 14.26 squared meters. So that's the area of the first one. Now area 2, we wrote down the formula before, which was over here, and area 2 is half times pi times radius squared. Half times pi times radius squared. So this is equal to half times pi, and we're going to be using the pi actual button on our scientific calculator if you have one. Half times pi times radius squared. Now the radius in this case is this length from here to here. Now what is that length? What is that length? Well, 4.6 is the full length, this is the diameter, so half of 4.6 is 2.3. So our radius is 2.3, and we've got a square, or 2.3 times 2.3. So this here is the area for area number 2, the semicircle. So how we go with putting this into the calculator is we're going to put fraction 1/2 multiplied by pi. Now pi, if you don't have a scientific calculator, you'll just go ahead and use 3.14. But if you do have a scientific calculator, you notice that the pi button is right here on the bottom. right here. And in order to get that, you need to press Shift and this button here, and that will pop up with pi. And this pi here is a more accurate version of pi. It's to more digits, so you're going to get a more accurate answer. And 2.3 squared, you're going to use this button here, the square button. If you don't have a scientific calculator, you would just type in 2.3 times 2.3. If you can't put in a fraction button, you would just put 0.5, because 0.5 and half is the same number. Go ahead and press equals, press the SD button, and here we get 8.31. And the reason why it's 1, it shows 0 here, but because the critical digit here is greater than 5, this is 9, this bumps the 0 up by 1 unit to 1. So this here is 8.31 square centimeters. So to get the area overall, which is area 1 plus area 2, so area is 14.26, which is from here, plus 8.31, which is from there. And let's go ahead and put this in. 14.26 plus 8.31, and this will give me 22.57 square meters, which is this one here. So this set skill will take a while because there's quite a few questions. I'm going to go ahead and try 2 more examples so you get a really good feel for this composite shape skill. Let's see which questions we can attempt. Alright, question 8. Which is the correct area for this sector? So a sector is just a section of a circle. We call it a sector. This here, think of portion. Think of the word portion of a circle. This here, we've got a certain degree within the internal space of the circle. Now, if you remember from the formula, this here, we're going to grab whatever the degree is, divided by 360, times pi times the radius squared. Now, if you tune in, we know that 60 degrees out of 360 degrees is 1/6 of the circle. If you're really smart with your fractions, you can just type in 1/6. But if you want to be consistent, all you have to do, look at the area, is put it in as 60 out of 360. Times this by pi, and times this by the radius. The radius here is 3, and it's the radius squared, which is 3 times 3, which is technically 9. So let's go ahead, let's put this into a calculator. 60 over 360 multiplied by shift, and that button there, to get pi, multiplied by 3 squared SD, and we get 4.71, which is this. Yeah. Alright, this is question 12, and this is the last example that I'm going to show you. I know there's going to be quite a few questions that you're going to struggle with from question 12 onwards. It is being designed, or has been designed rather, to challenge you. Okay, now by all means you can ask me for help, but with this said, try to think of an approach to the questions first before you come and ask me how to approach it. So this last example, we're going to get the area of the shaded part of the composite shape. Now what's different about this shape is that there is a piece missing, a circle piece that's missing. So in this case we have to work out the area of the bigger shape, work out the area of the smaller shape, and do the bigger shape take away the smaller shape. It's not being added, it's being taken away because it's a part that's missing from the overall shape. So area 1, which is just this rectangle, which is 14 centimeters and 10 centimeters. This one's really easy. This is just 14 times 10. So my area 1 is just equal to 140 square centimeters. Now, the circle part here, it doesn't necessarily show you the radius specifically within the circle. But what we do know is that if the width of the circle, which is also consistent here, is 10 centimeters, then the radius, which we need for our formula, must be half of 10, which is 5. And so area 2, which is the internal circle with a radius of 5. Area 2, following our formula, is pi times radius 5 squared. Now onto our calculators, shift that button there to get pi times 5 squared, 25, because 5 squared is 25, and this will give me 78.545. 78.54. Now, I've seen some students go into autopilot and just grab these two areas and add them together. This is not the case. We need to get the shaded area, so we have to get the bigger area, 140 square centimeters, and subtract 78.54 square centimeters. So gotta be careful. We're doing a subtraction, not an addition. So here, this is 140. Take away 78.54, and this will give me 61.46, which is the solution here. Alright guys, this is the last example. Go ahead and attempt the skill. Remember, the skill is finding the areas of composite shapes. If you need any help, you know where I am. And best of luck with this skill.